Howdy, can y'all hear?
Aye, aye.
All right, good. All right, so I'm just going to start talking, and unfortunately, I cannot see y'all on the stream thing. So whenever y'all have something to say, you'll have to pipe up. Okay, ready to get going now? Do I have clicker control yet?
Second.
Okay.
Wait, I can't see the slides.
You're not going to be able to.
There's a flaw in your.
Is partially flawed, yeah.
You should have live streamed it. Sorry.
Okay.
Can
Do I have clicker control now?
Zachary?
Huh?
Can I view it from your phone?
Sure. Go right ahead. Okay.
Yeah, you should have.
We good?
Yeah.
Okay. Welcome to our very first quarantined Ratio Christi. Just a second here. There you go. Welcome to our very first Ratio Christi within the quarantine. My name is Zach, and we're going to see how this goes. I'm usually not really used to this type of environment. I'm used to having a lot of social feedback, so I'm going to be a little uncomfortable, but that should be fine. So welcome. Ratio Christi, as you probably are aware, means reason for Christ in Latin, and we serve to defend the Christian faith in honest dialogue with both skeptical and believing friends. We do not meet at 8:30 anymore because the coronavirus has caused massive panic and shutdown here on campus, so ignore that. I've lost clicker control already. Yes. Here are all the ways that we can connect. Of course, our primary way of connecting is now going to be through YouTube and Zoom for the remainder of this semester. So if you can see this, then you're already there. Our podcast is the Think Theism podcast. You can find that online at thinktheism.org. You can search for Think Theism in any of your podcast providers, Apple Podcasts, Spotify, etc. Typically, we will host the audio of our meetings if they're any good, and we also have done some interviews recently with Dr. Behe and Dr. Swamidas from our Veritas forum. So all of those are now uploaded, and those are some of our favorite interviews that we did. So honestly, y'all should check them out. They're really quite good. Okay, ignore that. None of this is happening. Okay, so for tonight, we're going to talk about the design argument for the existence of God, and specifically, we're going to be talking about the fine-tuning version of this argument. So as a way of sort of orienting ourselves again, this is our belief map. And the belief map basically covers the four categories of things or questions that a equipped Christian needs to address through apologetics. So those specific questions are grouped in two different topics, general theism and Christian specific. So general theism is things just like the existence of God in general, and Christian specific are things relevant to Christianity. And then we have two different versions. We have positive arguments and we have defensive arguments, where positive arguments are making the case for a particular view, and defensive would be responding to objections. So for example, if you want to provide an argument for why Christianity is true, that's positive Christian specific. If you're responding to an objection specifically to something in the Bible, that would be a defensive Christian specific view. So this argument fits squarely in the positive general theism camp. What that means is that it is a positive argument, so we're making an argument for the existence of God, but it's a general theism, which means that the conclusion of this argument is not going to be, we believe in one God, the Father Almighty, maker of heaven and earth, visible and invisible, etc., etc. It's not going to be a Christian-specific argument in that respect. So it's important up front to acknowledge the nature of the argument, but also the limit and the scope of the argument. Sometimes people think, I've made an argument for the existence of God, therefore be a Christian. This argument doesn't quite get you there. So design arguments in general have a lot of different approaches that you can go about it. This is actually just a joke. Sometimes you'll hear things like, if Earth was 10 feet closer to the sun, we'd burn up, man. Isn't God cool? And those are obviously not sophisticated versions, but they are picking up on a somewhat true fact and then obfuscating them by 3 or 4 miles. So we'll discuss that in a little bit more detail. So in general, there are, broadly speaking, two types of design arguments that you can give. The first one is what we're probably most familiar with, called a teleological argument. And that is basically an argument from, as it says here, the Greek being telos, or goal, and it says that there are certain features of our universe that appear to be purposeful. And for that reason, we can infer that there's some type of supernatural designer that has made our world or our planet or life or what have you for a particular reason. Now, another version of the argument, which is interesting, is called the eutaxological argument. And this just says, if you look at the beauty of the universe and the beauty and the simplicity of the natural laws and equations that govern our cosmos, we can infer that there is some type of a creator who is an ordering being. He or she or it is some type of a mind that wants the world to operate well. So if you are familiar from like the deist controversy, the clockwork universe view of the world that came out in the 1700s was very much according to this. We can see that the world behaves according to the Newtonian mechanics. It's very predictable, it's clean, it's simple, and it's neat. Isn't that neat? So what we're mostly focusing on is going to be the first version, the teleological argument, but we may bring up elements of the eutaxological argument, if you will. But both of these could be considered design arguments, a design for a purpose or a design for beauty. And the basic structure of the argument goes something like this. There are some unique features of our universe. We have some epistemic framework that we use to evaluate the features of the universe, and the conclusion is that those unique features are attributable to design in one sense or another. So some of the examples that you may have heard of are irreducible complexity. That was something that Dr. Behe brought up during the Veritas Forum. There's cosmological fine-tuning, which is going to be our main focus here, orderliness of the universe, etc. Probably the most famous guy that's, he didn't really start it. Design arguments have been around forever, but one of the historical starting points is William Paley and his watchmaker argument. Now, his argument was primarily an argument from analogy. Now, there are a lot of different interpretations of Paley, but the most conventional interpretation is that if you look at something like a watch, so that's the story that he tells. He says, suppose that you found a pocket watch out in the middle of a field. By analysis, you can determine that all of the parts are intricate and they're all ordered for a particular purpose, and that purpose being to tell time. And we can infer from the fact that this device has purposely arranged parts that there was some purposeful arranger, if you will. So we see a watch, we can infer a watchmaker. And similarly, by analogy, there are elements of our universe, and Paley specifically focused on biology, that allow us to infer the existence of a cosmic designer. So one of the big examples that Paley brought up in his book was the complexity of the human eye. And he says you can see that all of these elements of the eye are ordered towards a particular purpose, which is to see things. And from there, we can infer that there is some type of being or entity or mind that orders biology. And he said, and his argument is essentially, like I said, it's essentially an analogy. We infer watchmakers from watches. We can infer life makers from life, as it were. And he gave a whole lot more examples besides just the eyeball. That just happened to be one of the most popular ones that stuck around. Now, just as a footnote, a lot of people think that Darwinism has defeated Paley. If you actually dig into the structure of the argument, nobody really explains how Darwinism defeats Paley's argument. So people will get really mad at him and say, he's dumb, he's stupid, Darwin got rid of him. But really, his argument is not affected by Darwinism. Just footnote on that. So another version of the argument, more contemporary, is a Bayesian likelihood approach. So this is put together, or this is promoted primarily by folks like Richard Swinburne and Robert Collins. And basically what they say is that there are certain features of our universe, cosmic fine-tuning and orderly laws specifically, and they feed it through the framework of Bayesian probability. So I have Bayes' theorem down here, and basically what it says is that what is the probability of some belief or theorem or something given some amount of evidence? And you put it through this full equation that's down here at the bottom. Now the biggest problem with any Bayesian analysis is determining what's called your priors. What is the prior probability of something before you consider the evidence? And in an argument for the existence of God, that means what is the prior probability of God before looking at the evidence? How on earth do you answer that question? It's a very difficult question. So if you notice here in the orange box, I've outlined that Swinburne has made that basically his life project to assess what is the prior probability of theism, and then how do the relevant pieces of information and evidence in the world affect that prior probability. Robin Collins has a much more narrow approach where he doesn't say that this raises or lowers the prior probability of theism. Rather, he just says the evidence of fine-tuning or orderly laws favors theism when compared to some other theory, for example, a multiverse or a naturalistic single universe. So we'll talk a little bit more about that in a minute. The last approach that's really popular is the formal design inference approach. So William Dembski is kind of like one of the architects, if you will, of the intelligent design movement. And he has this, basically his argument back in the 90s was people will use Bayes' theorem to evaluate probabilities of things, but they don't actually have a rigorous algorithm for eliminating improbable events. So basically, he says sometimes you'll have an improbable event that occurs that could be attributable to chance, but you don't really know. How do you actually distinguish between chance and design? And so he wrote this book called The Design Inference, which made a lot of people really mad in the 90s because he then used it to say that Darwinism is effectively wrong and you should instead affirm intelligent design. He got kicked out of Baylor. It was a big deal. You should read about it. It's a really interesting part of history. But Dembski was primarily focused on biochemical analysis, biology, things of that nature. Now, William Lane Craig, friend of the show, is a very well-known philosopher, and he's actually taken Dembski's system called the chance elimination argument, and he's applied that to cosmic fine-tuning. So we'll talk a little bit about these specific arguments in a minute, but essentially the chance elimination argument is a 10-step procedure for eliminating some low probability event from being attributable to chance. Craig is an excellent communicator. He has reduced that 10-step process into a 3-point process, or a 3-point argument. So we'll talk about that in a minute. Yes, I'm aware of that. So with that in mind, let me pause. Are there any comments or questions thus far on just these 3 things?
No.
No? Okay. Thank you.
So I have one real quick. So
Yeah.
William Dembski was a scientist.
Dembski? Yeah, he's
Yeah.
I'm going to mess this up. He's like an information I think it was computational informatics is what he focuses on.
My mic's off. Some of you guys have met Robert Marks at Baylor. He's involved with Ratio Christi at Baylor. So he and William Dembski worked on a number of things together, focused on evolution and information and how information is created or destroyed or whatever within that process.
Yeah. So, yeah. Any other comments? Okay. So let's move on. Can I have my clicker power back, please? Okay. So let's specifically focus on this idea of fine-tuning. So fine-tuning is, like I mentioned earlier, there are a lot of different features of the universe or features of life that are considered for the argument, and the most popular version is what's called cosmic fine-tuning. And this gets really, the definitions are all over the place. So one version by Luke Barnes is, in the set of all possible physics, the subset that permit the evolution of life is very small. John Leslie in 1989, he said, it looks as if small changes in this universe's basic features would have made life's evolution impossible. And then the more sophisticated version by Robin Collins is, the laws and values of the constants of physics and initial conditions of any universe with the same laws as our universe must be set in a seemingly very precise way for the universe to support life. And despite the metaphor, a lot of times people think that this is like tuning a radio. There is no hand that's on the dial. It's just a metaphor. If you say that there's a hand on the dial, then you're actually presupposing design before you even get to the idea of fine-tuning. So fine-tuning is really a commentary on the delicacy of the a delicacy of the equations that describe our universe. It's not really a comment on whether or not there is a fine-tuner, as it were. So another way of looking at it is there are different layers of fine-tuning. So there's fine-tuning specifically on our planet. Like if we were this far from the sun, we wouldn't be able to support life. There's the Goldilocks zone, things of that nature. What we're talking about specifically in this context is going to be this outer ring that I have highlighted here on the slide. These are the most fundamental things that govern our universe. So This isn't about where the planet is. It's more like what is the nature of atoms, or like what is the strength of the strong nuclear force, for example. Things that govern all aspects of our universe, no matter what planet or galaxy or solar system you're in. So the general argument goes something kind of like this. The first step is that our universe allows for the existence of conscious, embodied moral agents, or life, more generally. That three-part definition will be important later. The second part is tuning. The conditions under which a universe can permit this specific kind of life is exquisitely fine-tuned. The third part is the explanation. So the fine-tuning discovery is extremely surprising, and it needs some type of an explanation. And then, of course, the final step is that God is the best explanation of the cosmological fine-tuning that we discover. So let's skip that. So this is Craig's argument. This is the condensed form of the chance elimination argument. It goes like this. The fine-tuning of the universe is due to physical necessity or chance or design. Fine-tuning is not due to physical necessity or chance. Therefore, it's due to design. Pretty straightforward. Now, if you read the green book from earlier, God and Design, Craig has all 10 intermediate steps listed out there. But it's pretty straightforward just for communicating. Basically say these are the 3 live options to explain fine-tuning. You rule out physical necessity, you rule out chance, that kind of leaves you with the design. Personally, I find this method a little bit sketchy because you're not making an argument for design, you're just making an argument against chance and against physical necessity. The fact that design falls out seems a little too easy for me personally, so I don't really like this version for that reason. The second version, which is by Robin Collins, this is the likelihood version, which I think, although it's a little bit more narrow, it's a little bit stronger in the sense that it's more defensible in the fact that the scope is a little bit more narrow. So it's a little bit wordy, but I'll go through it. So first, given the fine-tuning evidence, a life-permitting universe is very, very epistemically unlikely given a naturalistic single universe. That is, there's one universe and there's no God in it. The second one is, given fine-tuning, a life-permitting universe is not unlikely given theism. Secondly, theism was both advocated prior to the fine-tuning evidence being discovered, and secondly, it has independent motivation besides the fine-tuning. In other words, it's not like we discovered fine-tuning and then suddenly everyone started believing in God. And then lastly, the conclusion is that a life-permitting universe it strongly supports theism over a naturalistic single universe. So this is a little bit more wordy, it's a little bit more narrow, but I think it's a little bit more defensible because of it.
Why is 3 important?
So basically what it's saying is that when you have competing hypotheses, you want to favor a hypothesis that is not ad hoc. So one of the arguments that will come up later is the multiverse is an explanation that mostly, I mean, there's some disagreement on this, but in general, most people say people only believe in the multiverse because of the fine-tuning. In other words, it is ad hoc to this. Multiverse is to explain the fine-tuning. So if you have something that was advocated prior to the evidence that needs to be explained, and it explains that evidence, then it's a stronger theory, or it's a stronger hypothesis. Does that make sense?
Indeed.
Okay. Clicker. Any other comments? Okay. So let's get to the second part. So the first part, everyone agrees life exists, right? Okay. So the second part will be the tuning. This is the more controversial part. Now, Collins in his in his chapter in the Blackwell Companion, he outlines 3 categories of fine-tuning: the laws of nature, the constants of physics, and the initial conditions. There are a lot more out there, but these are just some of the strongest examples. Now, as fun as it would be to go through every single one of these, that would take literally forever. So we're just going to focus on what's called the cosmological constant for 2 reasons. First, it's a little bit easier to explain than the others. And secondly, it is like the #1 most discussed example of fine-tuning in the literature. So we'll stick with this one for now. So I'm going to read this. This is from Martin Rees. This is an excellent book. It's really short. It's a little bit outdated, but it's pretty good. It's called Just 6 Numbers, and one of those numbers is lambda. So he says, measuring the cosmological constant, lambda, was the biggest scientific news of 1998, an unsuspected new force, a cosmic anti-gravity that controls the expansion of our universe, even though it has no discernible effect on scales less than 1 billion light years. Fortunately for us, and very surprisingly to theorists, lambda is very, very small. Otherwise, its effect would have stopped galaxies and stars from forming, and cosmic evolution would have been stifled before it could even begin. So basically, the simplest way to put this is that with the Big Bang, you have the universe as a singularity, and then it very rapidly expands shortly after that. Now, if it expands too slowly, then gravity will overwhelm the expansion force and it will collapse in on itself. Nothing will evolve. The alternative is the universe could expand way too quickly. And if it expands too quickly, then you don't have any of the atoms that will congeal and form stars and then later form rocky bodies like planets. In other words, you just have a universe with basically atoms, or hydrogen, effectively scattered all throughout the universe. So one of the terms that governs the rate of expansion is this number lambda. And as it turns out, the predicted value is really, 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 really big, like monstrously big, on the order of 10 to the 53 times bigger than what it actually is. And as it turns out, if it was very much bigger than that, we would have hydrogen world. If it was very much smaller than that, we would have collapsing world. What's the word I'm looking for? More technically, I guess, this is specifically where this term is coming from. This is the Einstein field equation. It's a lot of gross numbers, I'm sure. But if you notice right here, you start off with your curvature tensor. This is just describing the curvature of space-time. And then you have a couple of metric tensors that are added onto that. And then that's ultimately leading to your stress energy momentum tensor, which is governed by a couple of constants. Now, don't get too bogged down in the math. The important part is that the cosmological constant is that term. It's the constant in the third term, the little lambda right there. So it's a multiplier for one of the metric tensors. Now, I don't actually do physics, and I definitely don't do any type of general relativity. But my friends who are in those classes tell me that for most applications, they actually just neglect that term because that's how small it is. Just like Reese's book said, it doesn't really take effect at orders, I think, less than 1 light year, is about how far you have to be. And so if you're doing anything on Earth, you don't need to deal in light years. Now, what does it actually mean physically? And this is where things get a little wonky. So Einstein, truth in advertising here, Einstein initially proposed lambda just as a dummy variable so that his equation would fit the data. But as it turns out, physically, what it means is it's effectively the energy density in the vacuum. And so what physicists mean by cosmological constant is really small and it's fine-tuned is that they mean that the energy densities of several different fields cancel each other out, but they don't cancel out completely. They cancel out to a really, really small value. And because the amount of energy density that's being thrown around in these gigantic fields is so big, the fact that they cancel out to such a small value is really surprising. And if you really want to get into it, they're talking about lambda effective, which is the summation of the energy density in the vacuum. And it is, as well as just the bare lambda that's usually predicted, and then some other lambda that I forgot. Now, I know that's really detailed and stuff, but I think it's worth it for the time. What? What, is it too low? Oh, okay. Sorry. I've been informed to make this higher. Okay. Any questions about that? No? No questions or comments?
Nope.
Okay. Excellent. You all get a complimentary degree in astrophysics. Okay. So, all right. All that to say, I'm a master's student in biomedical engineering, so why should you believe me whenever I talk about any of this stuff? So there are 3 things that we use that I think are relevant whenever it comes to evaluating things that are outside of your field. And it comes down to this: consensus, independence, and extravagance. So first, do the overwhelming majority of relevant experts agree on what you're talking about? And as it turns out, yes. The overwhelming majority of cosmologists, doesn't matter if they're atheists, theists, some other weird religion or what have you, they agree that fine-tuning is a legitimate phenomenon. They explain it differently, but they agree it's a real phenomenon. Second is independence. So do the relevant experts agree on the data despite having different backgrounds and different reasons? And the answer is yes. Not only do the relevant experts with different beliefs agree on this, but they agree for different reasons. So you have the cosmological constant is just one example, but there are also biochemists that have commentary that is relevant in whenever it comes to the other the other constants and quantities that are under discussion. And then lastly is extravagance, and that is that many of you are probably already aware that the multiverse hypothesis is offered as an explanation for this. And that's a rather extravagant explanation, just a priori. So it suggests to me that people don't suggest a multiverse unless there is a phenomenon to actually be explained. So you can disagree with the multiverse, but if you're going to go to great lengths to rewrite our basic understanding of how the world works to explain something, that's evidence that it's at least a real phenomenon that needs explanation. Now, note of caution for intellectual honesty and consistency here. If you use this method to say that fine-tuning is a legitimate phenomenon, then you need to be careful whenever you discuss other things that are more controversial, things like evolution or climate change or any other scientific hypothesis out there that may get you into trouble or you may already have reasons for rejecting. So you don't want to say the experts agree with me here, so you should believe me, and then in another field say, yeah, I disagree with the experts, but the experts are wrong. You got to be consistent in how you argue. Okay, so that's tuning. And then the next part is going to be explanation. So this is where we're going to talk a little bit about epistemology, probabilities, and things of that nature. Personally, I think that the fine-tuning evidence, the physics part of it, is not really that interesting. I mean, it is interesting if you're a physicist, but as far as this argument goes, everyone's willing to say, okay, yeah, there's fine-tuning. Now, what do we do with that? And so to introduce a little bit of the nomenclature I'm going to be using, this is a basic way of representing a probability. So what is the probability of some phenomenon given a hypothesis conjoined with the relevant evidence? And then it spits out some probability between 0 and 100%. So here's a scenario I like to that I encountered that I think is a really good explanation for how to evaluate what types of probabilities are in play. So just follow me on this thought experiment for a little bit. So suppose that there is a jail, and at this jail there are two cells. One cell holds 1,000 prisoners, and the other one holds 1,000 prisoners. But the difference is that in one cell, 999 of them are guilty, and there's one innocent person. And then in cell block B, I don't know exactly how this happened, but 999 innocent people are in there, and there's only one guilty person. Now, as it turns out, there are two wardens that work at this prison, and they have decided, one of them is on duty, you don't know which one, and they have decided to release a prisoner. And as it turns out, you discover that today, this prison with two cell blocks and an unknown warden has released an innocent prisoner. So the question is, given the fact an innocent prisoner was released today, does that increase the probability that Mr. Random was in charge, or does it increase the probability that Miss Justice was in charge? So Mr. Random, of course, he releases things at random. Miss Justice, she only releases innocent prisoners. So think about that for a minute. Okay, so let's look at this with our equation. So what is the probability that an innocent person was set free, and given that Warden Random was the one that picked the prisoner, and with all of the evidence that we have? Okay, consider all the things that we know, combine that with the hypothesis that Warden Random was in charge, and then do the same thing. Take all the evidence that we do know, and then say, given the hypothesis that Miss Justice was in charge, what's the probability that an innocent person was set free? So think about that for a minute.
Since there are equal numbers of innocent and guilty prisoners, then the warden who chooses at random surely must have 50-50% chance, right?
Okay, which cell block did he choose from? So you don't know is the point here. Okay, so actually,
but they did choose from a specific cell block, and which cell block they choose from determines the probability.
Yeah. So here's the scenario. Here's the scenario. You know that there are two cell blocks, and a person walked up to you and said, "I was set free today, and I'm innocent." That's all you know. You don't know what cell block they came from, and you don't know who was in charge. Okay. So I'll actually cut to the chase because the answer is a little counterintuitive. The answer is actually 100%, given both of those hypotheses. And the reason is because of this second term, all that we know. What is the probability an innocent person was set free, given that we know an innocent person was set free? 100%.
100%.
So yeah, exactly. So what's the probability an innocent person was set free, given Warden Random set an innocent person free today? 100%. What's the probability if Miss Justice released an innocent person? 100%. So the problem here, or the issue that we're trying to get at with this, is that you have to select your relevant background information. So let's go back to our example here. And so now here's the new information that you didn't have, which is that the prisoner is actually from cell block A. So now, if we include that into our equation, how does that change things? If the prisoner says, I was the only innocent person in my cell block and I got set free today.
Miss Justice.
Probably.
It was probably Justice.
Right. So,
although, don't both wardens still have 100%?
No. So here's the equation right here on the slide. So the probability an innocent person is set free, given that Warden Random was picking someone from cell block A, is 1 in 1,000. It's really, really low, right? But the probability that an innocent person was set free, given that Miss Justice was picking from cell block A, is basically 100%, because Justice only sets free innocent prisoners, whereas Warden Random picks random prisoners. So in this case, once we have all the information, we can say the fact an innocent person was set free today from cell block A favors the hypothesis that Warden Justice was in charge. Does that make sense? Is there any question about this?
If we were to specify that the warden could have chosen from either cell block, does that mean that the random judge would have gone up to would have shot up to 50%?
Sorry. No. So yeah, okay. So the full example would take like 30 minutes to explain all the details. One important detail, though, is that they can only release one prisoner from one cell block.
Oh, okay,
yeah,
I see.
So they can't pick which cell block. The cell block's already been picked for them. Yeah. But the point of this is the whole purpose of this. Don't lose the forest for the trees here. The purpose is just to say that you need the relevant background information, which is you need to know.
Yeah.
Specifically in this case, you need to know, was an innocent person set free, and you need to know how probable an innocent person is being set free from that cell block. So if Miss Justice was in charge, so there's another part of this example which basically says if Miss Justice was in charge and picked someone from cell block B, you actually don't have any epistemic bump. There's no evidential bump to that. So let me back up here. So if someone says, I was an innocent person and I came from cell block B, that doesn't actually increase or decrease the probability that Miss Justice is in charge, right? Because Miss Justice only releases innocent prisoners and Mr. Random picks at random. But Mr. Random releasing an innocent prisoner from cell block B is just about as high as Miss Justice picking from cell block B. Does that make sense? So the whole question is, so the question is, what situation are we in? So given the fact that fine-tuning is really improbable, are we in cell block A or are we in cell block B? If we're in cell block B, it may not be a big deal. If we're in cell block A, then it is a big deal, right? So let's dispense with the example and move on to the actual thing here. So what is the probability of a life-permitting universe given a naturalistic single universe and the existence of life? And then secondly, what's the probability of a life-permitting universe given theism and given life?
The same.
What was that?
They're both the same.
It's 100% because we're alive.
Correct. Yes. Very good. You didn't fall for the trap. Yeah. What's the probability, given that we are alive, right? Yeah. So, okay. So this is an important thing, an important detour, because this is what's called the weak anthropic principle. Basically, I think Carter explains it fairly well. He says we must be prepared to take an account of the fact that our location in the universe is necessarily privileged to the extent of being compatible with our existence as observers, right? So, in other words, the existence of your observations necessarily, like biological necessity, must be compatible with the preconditions of those observations. So in this case, the probability of observing a life-permitting universe given a life-permitting universe is 100% no matter what theory you pick. So what's the probability of observing a life-permitting universe given the flying spaghetti monster and a life-permitting universe? It's 100%, right? So why does this fail? So the problem is sometimes people say, oh, well, fine-tuning, we can just erase it because you always observe a life-permitting universe, so it's never surprising. But the problem here is that it's a tautology, right? So it doesn't really, tautologies don't explain anything. And more importantly, it's the weak anthropic principle that's the tautology, not fine-tuning, right? So another way of putting it is, this is an example that Luke Barnes uses. He says, if you observe a bright star many, many, many light years away, and you ask, I wonder why that star is so bright, you can't answer it with, well, if it wasn't bright, I couldn't see it. That's not an acceptable answer. You have to actually explain the types of fission that are going on within it. Why is it so bright? You have to explain the mechanistic reasons for why it is bright, not it's bright, otherwise I couldn't see it. So that's the first part. And then the second part is there's an analogy that's really popular. I don't know if I'll bore you with it, so I'll just go through the quick version. Basically, suppose that you are lined up to be executed. Guy puts the gun up to your head, he fires, and somehow he misses. And let's say actually that there were like 300 sharpshooters that were all aiming their guns at you. They all shoot and they all miss. And so you observe yourself being alive and you think, oh, wow, I'm alive. Well, I shouldn't really be surprised because I couldn't observe myself being alive unless they missed. So I guess I'll just go on about my day. And the purpose there is just to capture the intuition that, no, 300 sharpshooters missing you is a big deal. That needs an explanation. Of course, you can only observe it if you're alive, but you still need an explanation for why they missed. So it's the same basic thing with fine-tuning. So now let's get back to our original claim here. So what is the probability of a life-permitting universe given a naturalistic single universe and what we call K prime? Well, we're defining that as the region of possibility space that is epistemically illuminated by our physics. This is a fancy way of saying, given what we know about the laws of the universe, given what we know about how things operate, and given what we know are fixed parameters and what are variables, what is the probability of a life-permitting universe given that? Turns out it's inscrutable. Inscrutable. No way you can assign those numbers. Don't try. I will call you out on it. There's no non-arbitrary way to do it. So our argument has died, right?
Just make them up.
Yeah.
Does that mean we can all go home?
Okay.
Logging off.
Yeah, yeah, log off, yeah. So, okay. So I bring this up because this is a serious question. When people start throwing around numbers like 10 to the 53 and 10 to the 120 and whatnot, probability arguments in my mind should always be assigned a higher level of scrutiny because people think that if you use numbers, you automatically appear more scientific, but numbers can be made up just as much as anything. So we have to be, the point here is not to say that the argument's terrible or anything like that. The purpose is just to say that you can't be excessively quantitative in your analysis. And this is the part of the reason why we have to be honest about not assigning these numbers when we can't assign these numbers. And just say that we deal with, we use the limits of probability as far as we can, but we don't push them so far that we become intellectually dishonest. So the purpose
How do we know that they're inscrutable?
I mean, because the part of the problem is whenever we talk about the prior probabilities that I talked about earlier, like what's the prior probability that God exists? And what's the prior probability that a naturalistic single universe exists? And it's really, really hard. Now, it's not impossible. So Swinburne, like I mentioned earlier, he goes into great detail, like assigning numbers on these points. But at the end of the day, I don't really think that they're any more solid than anybody else's numbers. I mean, they're definitely more reasoned. You don't want to put a 100% next to God, right? Because that's cheating. But at the same time, all this is just to say that probability is a very complicated field. And if you just start throwing numbers around, you're going to make an actual statistician really mad at you. So that's kind of the point there. But there is a way around this. So let's turn to the question of God. And it's basically to do this, which is just to say that the probability of a life-permitting universe, given a naturalistic single universe, and given fine-tuning, we don't know what that number is. But you know what we do know is that it's pretty small. Is it 0.02%? Is it 0.0000002%? That's what's inscrutable, assigning those numbers with any type of comparable precision. And we don't really know what the probability of a life-permitting universe is given theism and given the background information, but we know it's not that low because we can glimpse a reason why someone like God might create our universe and might want to design our universe. But what we do know is that given fine-tuning, given the chance hypothesis on a naturalistic single universe, that probability is way low, and definitely much lower than theism. What those numbers are, not so certain, and if we're going to be honest, we should not assign numbers to that, but we can at least say, relatively, that one is much bigger than the other one. Make sense? Comments?
Yep.
Okay. So let's talk a little bit about explanations. So one thing is, a good explanation needs to avoid being ad hoc. Now, people have believed in God prior to the fine-tuning evidence. Like I said, the cosmological constant was that fine-tuning was discovered in 1998. I was alive before 1998, and I think I believed in God before 1998. So obviously, I am an example of this. We could also talk about the entire Bible being written prior to 1998. So obviously, there are reasons to believe in God independent of fine-tuning. The fact that theism is a potential explanation of fine-tuning, therefore, it's a benefit to it, because it doesn't mean that we're creating this idea of God to explain something. All righty. So some objections to discuss. So I don't know if I really explained that very well. So let me just kind of go over this really quickly. Basically, the argument is this. Fine-tuning is really surprising, and it needs an explanation. A naturalistic single universe that happened to come into existence, fine-tuned for life, is exceedingly improbable. How probable? Not sure, but it's exceedingly low. The probability that God would create a universe that is fine-tuned and design it for embodied conscious moral agents such as ourselves is not low. Is it 50%? Is it 75%? Not really sure, but we do know that it's not very low. Therefore, the fine-tuning evidence is in favor of theism over a naturalistic single universe. All right, any comments on that before we get to the objections?
What would be an example of an objection which states that the probability is low of God creating a life-permitting universe?
Probably something like, well, you couldn't do it independently. Or sorry, you would have to do it independent of this argument. You would have to say something like, the probability of God creating a universe with suffering is really low. But that's completely independent.
Okay.
Yeah, that's independent of this argument, though.
Although it does inform the probabilities we're talking about, right?
No. Because the probabilities we're discussing here are just conditional on the evidence under consideration. So we're just saying, given the fine-tuning evidence, does that favor theism or does it favor a naturalistic universe? And we're saying fine-tuning considered by itself favors theism. So we can add it to the scale.
So you'd have to say that it would be that God would not fine-tune. You'd have to have some argument which says that, which feels like a difficult argument to make.
Yeah, pretty much. Yeah. So what we're just saying is that if you think of a scale of evidence, and one scale is God does exist and the other one is God does not exist, fine-tuning would go on the God does exist side. Now, suffering and evil may or may not go on the other side, and it may count against it. And it could be the case that they cancel each other out. There are philosophers that make that argument. But what this argument is just saying is fine-tuning considered by itself strongly favors theism over a naturalistic universe. Okay? Any other?
Works for me.
Okay, good. All right, next thing here. Okay, so let's look at some objections, all right? Now, there are 4 main objections, and none of them really object to life existing. There are some, but they're stupid. And nobody really will object that fine-tuning doesn't need an explanation. What people will object to is they'll either say fine-tuning isn't real, or they will say God is a bad explanation. And these four are that I have highlighted here are kind of the main contenders. So we'll go through them pretty quickly. So the first one is fine-tuning isn't real. You have your list of scientists, but there are a number of scientists that have looked really closely at these fine-tuning claims and concluded they are at least dubious, if not false. Fine-tuning has been debunked. No multiverse, no God is necessary. Response is no. And that's really all you got to say. No, I'm just kidding. So the
Well said.
yeah, works for you? Yeah. So the longer answer is that there are definitely instances of fine-tuning that have been shown to be artifacts. So like one example is, this is a really, really old example, but one time, I think it may have even been Johannes Kepler that came up with this. I don't know, it may have been somebody else, that said that like the rings on the moon they're perfect circles, and so they can only be created by an intelligent agent. And as it turns out, no, they don't. They could be created by meteors. There are other examples too. So one of them has to do with the stability of carbon, and it could potentially cause stars to explode. I don't know all the details on it. But there are definitely instances where physicists have done calculations. They think, oh, this is fine-tuned. Turns out it's not later on. And there are examples like that. But there are so many numerous cases of new instances of fine-tuning that are being discovered. And this excellent article by Luke Barnes in 2012, he surveys the landscape, illustrating the failure of most attempts to detune different constants. So the basic thing to say here is that the relevant experts who offer arguments form a almost near consensus that fine-tuning is real. And then even if you're not convinced on every single point, clues heaped upon clues can constitute a weighty evidence despite doubts attaining to each element of the pile. That's what John Leslie says. So even if you're only like 80% sure that this thing is fine-tuned, or even if you think that the ranges on something are not quite as narrow as they are, whenever you start adding more and more and more and more and more and more to it, they eventually reach a point where they're not, you can't get away from objecting to it by saying that each one is individual. This is just the nature of cumulative evidence. Okay? But what about it? I don't know what to say about that. It's fine.
Yeah, just don't mess with it.
Like that's not fine-tuning at all whatsoever.
Not particularly, no. There are well-known aspects of like tectonic whatnot that form mountains.
Right, but that just has to do with those plates moving.
Right, and it's well known. It's not like there's an agent, and it's not like there's something precarious or delicately tuned to do that. Okay. So basically, the argument is fine-tuning isn't real. Yes, it is. It kind of becomes a nose counting at that point. Okay. So the second objection is fine-tuning isn't normalizable. So it's actually the probability is inscrutable. And basically, what this is a pretty technical and nuanced question, but I think it's actually very relevant. So basically, all the fine-tuning discussion is meaningless unless you have a finite region for comparison. The natural assumption for any value is that its possible ranges encompass 0 to infinity. So for any finite range r divided by infinity is 0, which means that fine-tuning is meaningless. So to give an example here, suppose that I pick a number at random, and the number I pick is 5. What's the probability that I picked 5? Well, given the fact that there are literally an infinite number of numbers, the probability of 5 is 5 divided by infinity, which is 0, right? Now, suppose that I pick not just 5, but the range 5 to 5 million. Now, this is a substantially larger number of numbers, but 1 million numbers, or I guess 5 million numbers, or I guess 4,999,995 numbers, really, in that range, divided by infinity is still 0, which basically just says it doesn't matter how narrow those numbers are, unless you have a range to compare it to, those numbers are the same one way or the other, no matter how big they are or how small they are. This is sometimes called the coarse tuning objection. There's no difference between fine tuning, a parameter has a narrow range, and coarse tuning, a parameter has a wide range, because they're both normalized to infinity. I don't know if that makes sense or not. But this is a really, it's probably the most powerful argument, I think, against fine tuning. But basically the argument that to get around this is just to say that you don't have to consider the value of every single constant compared to every possible value it could possibly take. And you can form your parameters based on what I have here is the epistemically illuminated range. So Collins, if you remember earlier in the presentation, he says we're going to assume all of the laws in our universe operate the same way in these other hypothetical universes, and we're just going to vary the constants and see what happens whenever they come out. Now, obviously, there may be other universes with other laws, but given what we know about our universe, we can at least define a range of universes, or possible universes, surrounding our particular area. So I don't know if that makes sense exactly.
Isn't that what the multiverse theory is about? Is essentially because the universe we live in appears to be finite, correct?
Yeah.
So that immediately, I mean, it doesn't necessarily discard this Korstenian objection, but the multiverse theory is essentially an attempt to say, well, our universe appears to be finite, but there's an infinite or an arbitrary number of universes, so we can still make this objection.
Yeah, so the only difference is that this objection is even deeper than that, because it's saying the phenomenon of fine-tuning is not real, because fine-tuning presupposes that you know what the range is of any constant. So consider the cosmological constant, for example. It has some particular value, but the range of permissible values is really narrow. So you can go from, let's say 0 to 1. But if you don't know what the range is outside of that, 0 to 1 could be the same as 0 to 1,000,000, because you could be dividing by infinity. So it's a little bit deeper than that. But what this is saying is that what physicists are really meaning by fine-tuning is not the number of possible numbers or the possible values it could possibly take in every logically possible sense. They're saying, given what we know about our universe and given the laws as they are, we can vary these constants. And sure, we don't know the maximum range. We're not maximally epistemically illuminated to the point where we know every conceivable physical law and every conceivable constant. But in the area where we are, we do know what we're talking about. So in other words, like the simple answer is just to say, and this is kind of the spicy answer, is this objection is only relevant to philosophers who don't understand physics. That's basically.
I mean, the bigger issue is that you're trying to reason about, like some hypothetical repeated event from a sample size n equals 1, which is our own existence.
Well, that's a little bit different, but it is relevant. But yeah. Okay. Anyway, I don't want to spend too much more time here, though. But anyway, it's an interesting question, but you have to dig deeper into the philosophy of science to really get a solid answer on this question. Okay.
Would you have any recommendations for resources on this issue?
Yeah, so if you look down here at the bottom, you can't see where I'm pointing. So in 2005, or actually 2001, there was a paper by McGrew, and Vestrup called Probabilities in the Fine-Tuning Argument, A Skeptical View. That is the first paper that outlined this issue. And then Robin Collins, who's kind of been our guide through all this, he responded in 2005 with a paper called Fine-Tuning Arguments and the Problem of Comparison Range. Now, if you just read the 2005 article by Collins, he actually states the objection more, I think, more powerfully than the original article, and then he responds to it. And basically, he's just making this argument that we don't have to have a logically unbounded range of values. We can just consider what's under consideration, or we can just consider what we know by our own physics that we understand. Does that make sense?
Yeah, that makes sense.
Okay. So, so let's look at the next one then. Clicker power, please. So that's our second one. Okay, so those two objections that we discussed, they get at the idea of fine-tuning, whether or not it's a legitimate phenomenon. And we've already said it is a legitimate phenomenon, and the comparison range question is interesting philosophically, but whenever you properly contextualize the physical evidence, it ultimately is irrelevant. So let's talk about two arguments to God, okay? So the first one is the multiverse, right? And this is the big one in the room. Fine, you can say that God is an explanation, but if you can say the universe is fine-tuned and you can say that God is an explanation, but if we take an improbable event and then we increase the number of events, eventually we will have the random outcome occur, or the improbable outcome occur, right? So if you have a dice with, or if you have a die with 1,000,000 faces on it, you roll it 1,000,000 times, you would expect at least one of those to come up, right? You play enough hands of poker, eventually every hand will come up. So likewise, it is no surprise that some universe in this many multiverse universe scenario is structured so that observers will arise in it. So this is kind of what this looks like. You can have a whole bunch of dead universes, no life in them, but as long as there's one, of course we're going to observe the one that it's in. So there are a couple of responses. I think the biggest one to point out is that the multiverse by itself does not actually explain fine-tuning, because you need both a multiverse and a selection effect. It's not just enough to have a bunch of trials. You have to have a bunch of trials that then select. So it's not even that the multiverse is a possibility. You have to actually say the multiverse is, in fact, generating all of these different events. So that's one thing. But basically, the arguments come like this. It's not real science. It's metaphysics, so it doesn't enjoy any more scientific credibility than theism. The second one is that even the multiverse scenarios that are under consideration, they just move the fine-tuning problem up. They don't really get rid of them. There's this issue of Boltzmann brains. Probably we'll skip that one because it's kind of weird. And then the second one, and then the fourth one, is that there's in fact more fine-tuning data that we can consider that even the multiverse doesn't consider or doesn't explain. So we'll go through this pretty quickly. The first one is the multiverse real science? It's kind of difficult to really test the multiverse. And you might say, but God's not science either. Well, that's fine, but what we're saying is that it's not like the multiverse is a scientific alternative to God. It's just another metaphysical explanation. So it doesn't really, people go back and forth on this. I don't even know how to define science properly. People get mad about it. But Barnes, in his 2012 article, considers this and basically just says that we can't observe any of the properties of a multiverse because they have no causal effect on our own universe. That's like the definition of a multiverse. By definition, it's something that is not causally interactive with our current universe. So by that reason, the hypothesis of a multiverse will always be untestable. Once it starts causally interacting with our universe, then it's no longer a multiverse. It's just more of our own universe that's further out than we previously considered. So in a real sense, if you attribute God as being causally active in our universe, is technically more scientific than the multiverse, if you go by that definition. So, interesting thought. Perhaps the second response here is probably a little bit more on the nose, and it just basically says that if you go to the multiverse to explain one improbable event, you could probably keep using it to explain every improbable event. So, if Jones goes to the lottery and he wins 12 times in a row, well, he just happens to be in the one universe where he wins 12 times in a row. Obviously, no shenanigans going on, right? We play poker and I beat you 15 times in a row, and I always have a straight flush every time, or royal flush, or whatever it is. I don't play poker, right? So if I beat you 15 times in a row, right, that's not suspicious. We just happen to be in the multiverse where, I just happen to be in that one universe where I do win.
Quantum suicide.
Yeah, exactly. Yeah. So that's the second response. Is just to say that if you use the multiverse to explain one improbable thing, you can use it to explain a lot of improbable things, and then you're in a bad spot there. The other thing, too, that Barnes points out in his article, and Collins also points this out as well, is that the multiverse scenarios that are explained also have fine-tuning built into them. So the four conditions that any inflationary multiverse has to meet is that they have to, number one, cause the expansion of a very small region of space into a very large region of space, similar to the cosmological constant discussion we had. Secondly, they have to generate the very large amount of mass energy that is needed for that particular region to contain matter instead of merely empty space. Thirdly, they have to convert that mass energy of the inflated space to the sort of mass energy that we find in our own universe. And then fourthly, they have to cause sufficient variations among the constants of physics to explain the fine-tuning. Now, the details are just incomprehensible as far as you basically have to go get another degree to understand it all. But the long and short of it is, basically everybody comes out on the other end saying that all of those conditions need fine-tuning. Sometimes even more fine-tuning than the data that's under consideration in our own universe. So you can read more in the Barnes article about that. He has a really long section on the multiverse. The third one is the revenge of the Boltzmann brains. So Boltzmann, this is a philosophical thought experiment where basically, if you have random fluctuations of mass energy that are occurring in a broad, unbounded multiverse space, it's actually more probable that a single brain would come into existence, and then that one brain would have the experiences that it would interpret as the external world, but are in fact just its own subjective experience. So it basically just says that the multiverse would be more likely to predict a single solipsistic entity that has a reflection of itself rather than a vast, giant universe that we actually inhabit. It's a really interesting thing, but no one really cares about it in the physical world. It's just an interesting philosophical thing. Okay. And then the last one is fine-tuning for discoverability. So you could even go so far as to seed the fact that the multiverse explains the fine-tuning under consideration. You could seed that. And then say, but there are still interesting aspects of our universe that are fine-tuned, first of all. And second of all, make it interesting that we wouldn't expect it to occur in a multiverse scenario. So the big one is discoverability. So not only do we live in a fine-tuned universe for life, but it is also fine-tuned for discovery. Now, this long, giant paragraph here is from a presentation given by Robin Collins, and he talks about a couple of interesting things. So like one of them is that the maximum resolving power of light microscopes is about 0.2 microns. But that's actually governed by, I think, let's see if I have it on here. The fine structure constant. That's right. So the fine structure constant is another one of these terms that's fine-tuned. And as it turns out, if it was a little bit higher, our light microscopes could not resolve to the level of 0.2 microns. And that's interesting because 0.2 microns is the same resolution that you need in order to view a living cell. So basically, all of biochemistry would largely go down the drain because we wouldn't be able to observe cellular activity with our light microscopes. We could use electron scanning microscopes, but that actually kills cells in the process. There are other interesting things. So another thing with the fine structure constant is it governs the amount of radiation that's given off whenever you burn biomass. So whenever you start a fire in your fireplace, if that number was a little bit too big, then your fireplace would give off too much energy, and we would have giant forest fires every time you lit a match. If it was too low, sorry, I got the other way around. If it was a little bit too high, it would give off too much energy, and then your fire would go out. If it was too low, then every time you struck a match, then we would have this hellish landscape of unending forest fires because the amount of energy that's being given off is not high enough. So it's really difficult to build a scientific society if we don't have fire, basically where that comes from. And all that to say that even if the multiverse allows for a universe where life exists, it doesn't guarantee that you're going to have a universe where life exists and discovers interesting things, or even creates civilization. Okay. All right. So any comments on that? Questions?
No.
Excellent.
I got nothing.
Okay, good. All right, so the last objection to look at is God is a bad explanation for other reasons. So God did it is a bad explanation. So one is, who designed the designer, right? So you have this complex world, must require a designer. Well, that designer must be infinitely more complex than its creation, so who designed that, right? So this is dumb for numerous reasons. So the first one is, this argument, this is why the ad hoc thing is relevant. It only applies if God is posited to explain fine-tuning. But since there's independent motivation for belief in God, this is kind of irrelevant. And there's an argument to be made, even if God was postulated just to explain fine-tuning, that it would be irrelevant. Because in order to explain something, you don't have to keep going. You don't have to explain the explanation in order for it to be a good one, right? Otherwise, you just never be able to explain anything. So the argument itself, kind of defeats itself in that respect. And then the second point is that the presupposition that a complicated thing must have a more complicated designer is not immediately obvious. So, for example, machine learning. Like, machine learning can be designed and created by somebody who knows nothing about what's going on within the actual machine that's doing the learning. That's actually the benefit of it. It's a beautiful black box system that has enormously complex output, but the designer itself doesn't even have to be complicated in that respect. Or even artificial intelligence, or many other things can be like that. So even the basic idea is not even there. And then lastly, for all you Thomists, this begs the question against divine simplicity, which says, God must be complicated because he designed this complicated thing. But divine simplicity asserts the exact opposite, that God is not made of parts. He is literally the most simple thing because he's an undifferentiated essence, which is God. And God is God, right? Oh, Dimitri's probably not in the chat, is he? Ben is, right?
I'll just speak on behalf of Dimitri for a second and just say, yes, that's what Papa says.
What Papa French said. Yeah. Okay. Clicky. Okay. There are a couple of other more objections, like we only have one universe. How do we do probability in this case? One thing I kind of skipped over is the idea of epistemic probability versus objective probability. It's an interesting but really nuanced thing. 99.999% of our universe will kill us instantly. How is this fine-tuned? How can you say it's fine-tuned for life whenever there's only one tiny itty-bitty part that supports life at all? And basically it's just saying that fine-tuning is talking about the necessary preconditions for life. It doesn't even say that our universe is packed end to end with life from center to circumference. Just not necessary. The other thing, too, is that it doesn't actually understand how atoms are made. Carl Sagan has this wonderful quote, "You need an entire universe just to make an apple pie because you have to start with the Big Bang in order to even get the carbon that eventually turns into, or the carbon and the iron that eventually turn into a planet and then turn into a tree and then turn into an apple, and then you have to have an energy system like a stove." Wonderful little video. You should watch it. Thirdly, fine-tuning. These fine-tuning cosmologists, you're only looking at one constant at a time. Aren't there many, many others? And again, that's kind of irrelevant. We're just talking about the constants of the known laws, so we're just probing the space in our own epistemic world. And then the last one, which my personal favorite, life finds a way. Doesn't matter how inhospitable our universe is, right? Life will find a way. So notice how contradictory this is with point 2. Someone will say, our universe will kill us instantly, and then also say that life finds a way. Well, it can't be both. You've got to pick one or the other. So if you say that life finds a way, that we evolve to our conditions, not the other way around, what this doesn't understand is that fine-tuning is talking about the very structure of the fundamental elements of our universe. So it's not like a puddle that sort of fits whatever shape it happens to be in. Rather, it's more like, how do you have life if you have an entire universe filled with protons that never congealed into anything more than that?
Haven't you read Stephen Baxter's Zeely novels, Non-Baryonic Life Forms?
Yes, I'm aware.
The majority of the universe is living beings.
Well, yeah. So the question here is that, so even if you do that, which, there's an excellent Star Trek episode, too, which has a being of pure energy. The point here that we're talking about is our universe is fine-tuned for conscious, moral, embodied agents like ourselves, which is very unique. So even if there were immaterial beings or baryonic beings or angels even, the fine-tuning applies specifically to our unique form of life. Any other comments on this? Any other comments or questions or input?
Zach,
Yes.
Zach, is number 4 is the real proposition here panpsychism, rocks are alive, man?
No. What this is saying is, if you look on Earth, you will find there are forms of life even at the most extreme temperatures and conditions. So I forget the exact thing, but
archaeobacteria.
Yeah, exactly. So there are forms of life that exist in 200 degrees Celsius conditions, huge temperatures, or things that live at the bottom of the ocean. So what it's saying is, how can you say that our universe is fine-tuned when all the evidence that we see is that life will fill every nook and cranny and every wild condition that's out there? And what it's effectively saying is that the fine-tuning under discussion right now is not planetary fine-tuning, it's rather cosmic fine-tuning. So things like the structure of atoms. So it's one thing to say that some type of microbe can live at the bottom of the ocean under intense heat, intense pressure, but it's a different thing to say that microbe can exist without any proton in it, right?
So would the discovery of morally agentic extraterrestrial life undermine this? Undermine this?
No, not at all. In fact, extraterrestrial life would rebut the second objection, because you could say this universe is deadly and hospitable, and then you could say, well, no, there's actually more life that's out there. So what it would rebut, so there, like I said, there are different layers of fine-tuning. Cosmic fine-tuning, which is what we're talking about, like the expansion rate of the universe, that is applicable to everywhere in the universe. Now, there are some people who make arguments like the rare Earth hypothesis that say our planet particularly is fine-tuned for life. And that argument, that our planet is unique, that argument would be undermined by the existence of extraterrestrials. But that's not the argument we're talking about. So whether or not there are extraterrestrials, the cosmological constant still has to be a certain size, or there is no Earth. And there is no, again, I don't think that, to be more radical, there is no carbon. Like, you can't even start the building blocks of the periodic table at that point. Does that make sense?
Mm-hmm.
All right, cool. Click. Okay, so just to wrap up here, we can talk a little bit more if y'all want. Basically, the universe is pretty neat, and it's very delicately balanced to allow for both our own existence and for scientific discovery. And that's worth exploring even for non-apologetics, non-theology reasons. And these fine-tuning facts point in the direction either of a multiverse or the existence of God. Personally, I think it points in the direction of God, but there are some people who think it points to a multiverse. And it really doesn't matter which one you think is ultimately true, because both of those are pretty big, like, worldview-shattering conclusions. Either there is a creator and designer of our universe, or there are an incomprehensible amount of other universes that are out there. So either way you look at it, it's a pretty big deal. Now, I think we've discussed sufficient evidence to think why we should favor God over a multiverse. But even still, those are not necessarily incompatible with each other. God was definitely pleased to create an entire universe that's millions and trillions of light years bigger than us. Well, actually, billions of light years bigger than us. And why not make more universes on top of that? Okay, any other comments?
What if a naturalistic single universe just had to be the way that it is?
What do you mean?
What if it just, there's only one, and it is completely determined to have life, and that's just the way it is?
It was logically necessary for the universe to be this way.
Yeah, for reasons we don't know.
Yeah.
Or maybe we haven't discovered yet.
It's a completely unscientific assertion.
Yeah, I mean, most of these conclusions are not really scientific in the pure science sense. But that actually raises a more surprising question, which is, why is it the one universe that exists by necessity is as interesting, discoverable, and life-permitting as it is? It just seems very peculiar that of all universes, this is the one that should absolutely 100% exist. Right? So in that case, now you actually end up with another argument for the existence of God, which is, wow, our universe has baked into it by necessity the existence of conscious embodied moral agents, almost like somebody built it that way. Now, I don't go that route, but some people do go that route.
No other questions or comments?
I feel like I'd need to study this for a lot more time in order to come up with any worthwhile questions.
Okay. So a couple of resources here, resources and suggestions.
Stop. You keep clicking it, and it changes the things I'm trying to click.
Oh, sorry. We're having to share the clicker. Can I click?
Not yet.
Okay. So, any other questions about this or comments?
Okay.
No?
No.
Okay. All right. So, important references here. So, like the big technical article, if you're interested in the like physical aspect of it, is by Barnes, 2012. You will notice it's from page 529 to 564. It is a like massive technical article. It took me like a month to read it. So that's the big one that I would recommend. That's kind of the go-to for all these questions. As far as the argument goes, Robin Collins, that third one down, his entry in the Blackwell Companion is superb, and he actually discusses all of the epistemic questions that we kind of brushed over a little bit. If you're interested in the design argument more broadly, so that includes arguments such as the eutaxological argument, the teleological argument, or even the biological design arguments, then I would recommend that fifth entry there by Neil Manson called God and Design, the Teleological Argument in Modern Science. It's basically a compendium of a bunch of philosophers and scientists writing about different parts of the design argument and different versions of it. Of course, your mileage will vary, but there are like 4 or 5 papers that are really good in there. And in particular, the very last section has to deal with Behe's argument from irreducible complexity. So I'd highly recommend it for that one because Behe has an entry, and then Ken Miller has an entry too. So, and those have kind of been like the seminal starting points for that one.
Where can I find the Banana Man?
You ever looked at a well-made banana, you'll notice on the far end. Yeah. So, yeah, the Banana Man is on YouTube. He doesn't like being called the Banana Man, so don't call him the Banana Man. His name is Ray Comfort. He is a person.
I thought the Amazing Atheist was the Banana Man.
I don't know. Cool. So thank you all for coming to our very first Zoom YouTube live stream Ratio Christi from the quarantine thing. Next week, I don't know what we'll be doing, but we will be doing things. So, yeah, open to suggestions in the Slack. All right, well, if there's nothing else, we'll call that a night. Thanks, everyone, for showing up.
Of course. Adios.